Hello everyone, my name is Soto. I'm computer engineer teacher, and in today's class we are going to study a new lesson in our discipline, a data structure course. The subject is stacks. The objective of this class is learn the stack data structure characteristic and their implementation. Okay, first of all, we are to know in the data structure we have two different types of data structures. First of all, we have linear data structures, and then we have non-linear data structures. Well, inside of linear data structure we have arrays, we have queries, and we have stack, and this is the objective of this class. What is the linear data structure? To understand what is a stack. Well, first, in linear data structure, data is arranged in a linear sequence. Data items can be traversed in a single run. In linear data structure, elements are accessed or placed in contiguous, together or in sequence, okay, and in memory locations. So the intuitive idea of a stack responds to the need to place objects or entities in such a way that only one of the objects can be accessed. Okay, what it means that? Next, please. What is a stack? Well, a stack is called a last element, a last in first out LIFO collection. This means that the least thing we added pushed into the first thing that gets pulled. The correct termination for that is popped. Okay, popped off. A stack is a sequence of items that are accessible at only one end of the sequence. Well, let's understand what is a stack on the real life. For example, we have here those books and those ditches. Okay, if you have a stack of book, if you want to access to the one of element of the book, you must be in considering two things. What is the last element of the stack of book, and where is the top? So if you wanted to get of the middle element, you want to take the first, then the second, and then the other one. Okay, you cannot get directly access to the one element of the middle of the stack. Okay, well guys, the philosophy here in computer science is the same thing. You cannot access an element of the middle, okay, of any collection. Okay, you must to consider the top and the last one. Okay, but the most important here is know the top. Okay, next. Well, based on that explanation, we have different operations can be performed in the stack data structure. Okay, well, first of all we have an insert, okay, then we have the top, and then we have pop, and then we have empty. Okay, insert the element. Okay, insert the element, for example x. Okay, you must to insert, and automatically is the top or the stack. With the top method we can get access to the first element of the stack, the stack, sorry. And the empty is only a method you can to check if the stack is empty or no. So basically you have push to insert, for example, in other data structure like a list. Later we can talk about the difference between the list and the stack. We have the insert here is named push. The get element is named pop. Okay? And to check if the stack is empty or no, we have the empty method. Okay, next. Well, let's do a simple demonstration about we are talking about. Okay. Well, we have this stack CV with with those elements CV and A. For example, we have push D, push E, pop and pop D and pop C. Okay? Let's check C, V and A. If we want to add any element to the this stack, the element D, we must call to method push. If we want to add the element E, we must call the method push. Okay? And everybody knows what elements here we must do. For example, pop. Okay? Well, the element D. And if we pop the element D, what can I do? What element we can see on the top of the next kiwi, on the delta kiwi? Okay, the element C. Okay, remember that it's very important. Always the only element that you can see in real time in any kiwi you are programming is the top element. Next. Well, here we have other more details about the method of insertion or adding. Here in kiwi data structure we name it push. Okay, remember that if we have an element, if we have a new element on the current stack and we wanted to push, we first verify the top and convert the new elements on the new top. Okay, pop is the same. If you have this kiwi and you want to console the top, you always gonna to have access to the first to the first element. In this case is 12, in the 15, in this case is 12, 10, 5, or the double check the checking method named empty. Next, please. Here we have an application of stacks. For example, here on computer engineering we have a very simple application. Is with the reversing string. Okay, there is the definition of the reversing string. In the next slide, I'm going to explain with more detail about what is the reversing string. But let's to see what is the definition. Well, a simple application of stack is a reserving string. To reserve a string, the character of the string are pushed onto the stack one by one as the string is read from left to right. Okay, let's to the other slide to check what it means. That next, please. Okay, for example, we have one stack. Okay, and we have those elements. Okay, stored on the kiwi. On the kiwi, okay, on the stop. Sorry, on the stop. Okay, and with the name reverse. Okay, R is the bottom of the stock, E is the top, okay? Reverse. How the reverse strings work? Well, very easy. He started to see to read the top, okay? The method declare an temporary stock and push, okay, in the other stock the element, okay? And automatically the elements are storage on the temporary array. So if we want to read this string, we started for the top, the last one is E, push on the temporary and add on the first element of the array, and repeat dynamically that algorithm, okay, until of the end of the query of the stock. And in the final result is an array with the information of that string. In this case is the word reserve. Okay, we must to check in a validation, because in computer any element of one stock must be declared with a specific terms. Okay, in this case stocks are also used to check whether a given arithmetic expression contains nested parentheses properly, okay? Not could be other character, okay, like commas, like points, not only parentheses, okay? It's very important that, okay? And any stock have the possibility to check that when you are programming, okay? Here we have different examples, okay, to separate different elements, okay, using simple parentheses, simple declarations. Well, we have parentheses here, okay. With that expression, we have one element inside other one, okay, inside the top. So the invalid inputs in this case, if you open the parentheses here, you must to close it, okay? You cannot open the parenthesis and not finish, okay? Any question about that? Okay, let's do a simple exercise in C++ to declare, to make your own class design. Let everyone think just a moment about that. Okay, how can I declare a stock class? According, first of all, the rules are named here. If the top is the only element we have access. If to know where is the element of the middle, you must to, make that middle top using temporary, I don't know, a stock, etc. Okay? Let things only a minute. Okay. Well, let's see my recommendation of implementation. Next, please. Where we have here two different implementations according to the data extraction, according the way of the data extraction we must do programming. In this case, the sequential stack and the likened stack. What is the difference between one implementation at the other one. Remember here in data structure, a sequential array, okay? A sequential array, it's a joint of elements, okay, one by one, and they are located on the same space of memory. Well, here we're gonna to use memory, different memory space. What is linked? Okay, well, linked is, the philosophy of linked is, you can have the information about any different element in different memory spaces, and you can get access to them using a way what is the way? Correct, pointers, using pointers, okay? You can point to the element of memory, you can get access. It's basically the difference between one implementation and the other one. Okay, here is a sequence. Any element is only storage on the same space of memory. And here we have information about the elements in different memory spaces. Okay, and we have the both implementations I made. Okay, sequential and linked. Any question, please? Okay, well, homework for everyone, guys, is I made the implementation in C++, but I want to you guys use the Java program language to suggest other implementation of stacks and do other things in programming development, the top method. Okay, guys, you must try to develop a top method, okay, according to the rules. Any doubt about the homework?
It's okay.
Okay, next week, please. Okay, well, the final consideration, the conclusion. Taking into the consideration the rules we are now here and the previous definition about a stack, we can affirm that a stack is a particular case of list. Remember, in the other class, list is a data structure. List have rules, but the stacks, besides have rules, property rules, is a particular case of a list. So a stack, you can affirm, is a kind of list with their particular rules. And it's important to highlight that ED obeys the LIFO, okay, the LIFO order, last in, first out. Okay, very important, that philosophy. That last in, first out order. Okay? Otherwise, it will not be working with a stack. If you not use that philosophy, it's a simple list. It's not a stack. Okay? Next, please. Here you can consult the bibliography of that class. We have 3 different books of that structure. You can consult. You can search on each bibliography the different definitions used in those books, and try to do the homework according of the lesson we have it already. Okay. Well, thank you so much, and I hope you are enjoying the programming with stack. Thank you.